Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wondered why sometimes it feels like your research findings can be interpreted in a million different ways, even when you are sure about your theory? Well, this new paper dives deep into that exact frustration. It tackles a really fundamental question for anyone doing research, especially in psychology. When a study finds an association between two things, like more stress and more burnout, how can we be sure that association actually means something for the theory behind it, not just a statistical fluke or a weird coincidence? It turns out just reporting an association doesn't automatically make it evidence for your grand idea. So here's the big picture problem. The researchers noticed in psychology we often can't do perfect experiments. We can't always assign people to be stressed or not stressed, for example, for ethical reasons or because it is just not practical. So we look at real-world data, observational data, when we find that two things are linked, like stress and burnout. We're careful and say they're associated, not stress causes burnout. That is good. It is honest about what the data can show. But this paper asks an even deeper question. Even if we're just talking about associations, not causes, when can an observed link actually be considered evidence for a specific psychological theory? And the answer they propose is kind of mind-blowing. It is not just about the statistical result, it is about how well that statistical result actually matches what the theory is trying to say. To show why this matters, they give a really simple example. Imagine a researcher studying work stress and burnout. They expect more stress means more burnout, a positive link. Now they have data on two other things too: turnover, intention, and job demands. The theory itself doesn't say exactly what to do with these extra bits of information in a statistical model. So the researcher could just look at stress and burnout. They find a strong positive link, great, right? But what if they also include turnover intention in their model? Suddenly, the link between stress and burnout looks almost zero. No clear association at all. And if they include both turnover intention and job demands, now the association looks negative. Stress is linked to less burnout. That is a complete flip. This is the core issue. The same data, the same underlying reality, the same theory that says stress and burnout are linked. But just by choosing how to represent the statistical model, they get wildly different results. This happens because each statistical model is estimating a slightly different thing, a different parameter. Saying association doesn't magic away this problem. The authors call this the theory to model gap. It is the space between what your theory is actually saying and the specific statistical picture you are trying to paint with your data. If your theory doesn't clearly say how it should be translated into statistics, you can end up with multiple statistical models, each giving a different answer and no way to know which one, if any, truly represents your theory. So the statistical result, like a p-value or a regression coefficient, is only meaningful for your theory if the way you've set up your statistical model actually matches what your theory expects. Statistical analysis tells you what is going on within the model you built. It doesn't tell you if that model is the right translation of your theory. And it gets even crazier. The example used only 2 extra variables, but the paper points out that with even a few more variables, the number of possible ways to statistically represent a theory explodes. We're talking millions of ways. Think of it like this. Your theory is a destination, but the statistical model is like the map you use to get there. If your theory doesn't clearly define which map to use, you could end up taking a bunch of different routes, and each route might feel like a valid way to reach your destination. But they could lead you to very different places, or make the journey seem totally different. So how do we bridge this theory to model gap? The paper suggests we need theory specification. This is the process where a theory becomes explicit enough to clearly point towards its intended statistical representation. It is not enough for a theory to say A is related to B. It needs to give us clues about how other variables might fit in and why. In their stress and burnout example, the theory clearly stated the link between stress and burnout. The ambiguity came from the other variables, turnover intention and job demands. The theory didn't say whether they were causes, effects, mediators, or irrelevant. These are the things that need to be straightened out in the theory itself. This means researchers need to think critically about their theories. They need to consider alternative explanations, look at previous research, and use their understanding of the subject to figure out exactly how all the pieces of their theoretical puzzle fit together. This scientific reasoning, when made clear, helps narrow down the possible statistical models. And here is a key point. The choice of which statistical model is the right one for your theory comes from the theory itself, not from the data or statistical tests. Statistical tests tell you if your data fits a given model, but they can't tell you if that model is the one your theory actually intended. To make this practical, the authors propose a framework to evaluate how well a theory has been specified. It is not about whether the theory is correct, but about how clearly it lays out the reasoning that leads to a specific statistical model. They describe different levels of theory specification. At the lowest levels, the theory is vague. But as you move up, the theory becomes more explicit about why certain variables are included or excluded in a statistical model. The real magic happens at level 3. This is where the theory is clear enough that someone else, a reader, could figure out exactly what statistical model the researcher intended to use, based solely on the theory's assumptions about how variables relate. At this point, the theory-to-model gap is closed. This helps researchers be more transparent. They need to explain why they chose a particular statistical model, not just that they chose it. This makes their reasoning open for others to understand, critique, and build upon. So, what is the big takeaway? Just reporting an association isn't enough. Researchers need to show that their theory is specific enough to point to a particular statistical model. Otherwise, you can get wildly different results from the same data, and we can't be sure which result, if any, actually supports the theory. This idea of theory specification is crucial. It's not just about doing statistics correctly, it's about building better theories. It means that before you even run your stats, you need to have done some deep thinking about what your theory actually implies for how you should analyze your data. This makes observational research much more rigorous. This has big implications for how research is done. When planning a study, researchers should think about which statistical model their theory implies. When reporting results, they should explain why their chosen model was the right one to test their theory. This clarity will help everyone, from reviewers to future researchers, understand and trust the findings. Now, like any good science, this paper has some limitations. The framework they propose is about how explicitly the theory is stated, not whether the theory itself is actually true or correct. A very clear theory might still be wrong, and a not so clear theory might accidentally stumble upon the right statistical representation. The goal here is about making the reasoning transparent. They also point out that checking if the theory is clear enough is one thing, and checking if the actual statistical model used matches that clear theory is another. Both are important for making sure a statistical finding is truly evidence for a theory. So, what does this mean for us? It means we should be a bit more critical when we read about associations in psychological studies. We should ask ourselves, does the theory behind this finding really lead to this specific statistical result? Or could other statistical models have shown something different? This paper is a great reminder that good science isn't just about collecting data and running tests. It is about having a deep, clear connection between our big ideas and the numbers we use to test them. It helps us close that gap between theory and the models we use, making our understanding of the mind more robust and reliable. What do you all think about this idea of theory specification? Does it make sense to you? Let me know in the comments below. And if you enjoyed this deep dive, please give this video a big thumbs up. Subscribe to RUBIN'S Mind Lab for more science breakdowns and hit that notification bell so you don't miss our next video. Thanks for watching.